Hello, everyone. Fantastic to have you here. Welcome to today's webinar. Today, we're going to be going through three key steps for effective microservice testing. We're going to be showing you some great strategies to really get a hold of your microservice ecosystem and test it thoroughly. So, little introductions here. My name is Chris Colosimo. I'm the product manager here at Parasoft, focused on functional testing. And today I'm joined by Wilhelm Hacker, who is our solution architect lead, who will be taking us through some pretty great demos showing you how these solutions can help you take control of your ecosystem. And now a little bit about Parasoft. We are a software testing tools company. We've been in the business for over 32 years, really focusing on creating innovative solutions for software testing, all the way from when the first line of code is written through API testing, unit testing, UI testing, load and performance solutions for just about everything. We've got about 36 patents, which shows that we're highly innovative, and I think you'll see some of that in the solutions today. We really help organizations bring in continuous testing and quality at speed through technology, but also through partnering with them to build testing strategies. When it comes to building an automated and scalable test automation strategy, we really align with the principles outlined in the test pyramid, which you can see on the right here. And basically, you can think of this as how do I structure my testing practice, the inventory of tests that I have. You really want to focus with a broad set of unit and API tests to really validate individual components, get good coverage, because these types of tests really help you understand the root cause of defects in your environment. And so you want to build as many of those as possible, and then support them with your automated UI and manual tests at the top. But there are some challenges associated with that, and that is that when it comes to looking at how organizations are actually testing, we see sort of an inverted pyramid where there's a really heavy focus on manual testing and automated UI testing. And then we see less and less focus as we move down the layers of the pyramid. And there's reasons for this, right? We know that those tests at the high level of the pyramid they're easy to create, a little difficult to maintain, because we understand how we can tie together user activities to an automated test. As we move down towards the bottom of the pyramid, we see less of these because these tests are a little more difficult to set up, to understand aspects of the code, and we definitely require a high level of technical expertise. But what's interesting is as we drill in a little bit further, we see that how organizations are really testing ends up creating this goblet shape where we're almost exclusively focused on manual and UI testing. We skip right past the API testing. We see folks are doing some work here in unit testing, but really that API testing, there's opportunity here. So why do we see that? Well, it's unfortunate because this area of API testing really is one of the best ways that QA and test organizations can truly understand from an applications perspective what may be going wrong and where defects are being introduced. The API tests run much quicker. They're easier to understand what services they're connected to. And you can thoroughly test the application end to end and with each individual service. And when it comes to actually remediating a defect, handing off an API test to a developer helps them really shortcut the process. So why, again, are we seeing that goblet shape? And it's because of the types of technical skills and specialized tools that you need in order to thoroughly validate APIs. API is somewhat of an overloaded term. It doesn't just simply mean REST and SOAP. We have all sorts of microservice-based protocols, even communicating with a database or an event architecture inside of our system needs to be validated. So who does that and how do they do that? It ends up falling into a little bit of no man's land where it's in this weird gray area between dev and test. Now we know that both of these teams have a responsibility in that, and we're going to show you kind of how that fleshes out today. But the value from API test actually API testing really ends up hitting the bottom line, because there's business ramifications to not testing at the API layers. If we look at this testing pyramid, how it actually maps to our architecture, we see that our front end services, our Angular and our mobile, they're all powered by those back end services and APIs. And so the ROI gets a little misunderstood. We see our ROI losses that are really easy for us to understand are that the UI tests, although required, tend to diminish our ROI because they require constant maintenance. They can fail and provide false positives that may not necessarily be a UI manifestation. It's typically suffering from issues that are manifesting in the back-end services. They're not providing data properly to the front end. And so what happens here is that we get a little bit of an ROI loss because we're wasting the time determining, well, where's that root cause actually taking place? Is this a manifestation of an API problem? So there's opportunities here to go beyond the ROI that we get from UI testing by understanding that if we thoroughly validate our back-end APIs and get complete confidence on those, we'll have much less instabilities in our UI testing, and it will provide more value to us. And by doing this, we can actually get higher levels of test coverage across the spectrum. This ultimately leads to the reduced, what we call MTTR, reduced mean time to remediation, because we can hand off artifacts to development that will allow them to remediate things a lot faster. And this could not be more paramount when we start thinking about the industry trends for 2021. You keep hearing this, right? COVID forced us into digital transformation. We now interact with our customers via digital experiences, and even development and delivery platforms are becoming digital, as we see things like cloud, hybrid, multi-cloud ecosystems, continuous delivery being moved into cloud models, low-code development and delivery such as Salesforce and the like are trends that we're seeing organizations moving into. And what do you think's powering all that? It's all the APIs. And so by really focusing on API testing now and getting a strategy for that, you'll be able to maximize those ROI opportunities. Now, microservices comes in and sort of changes the deployment game. What microservices strive to do is to break down our traditional monolithic applications into small, individually scalable, individually deployable services. And those services then can communicate with each other and can be rapidly iterated on and redeployed, scaled, and so it just calls into more attention those APIs. Now, when it comes to testing microservices, there's a whole raft of new challenges that show up. You have so many more handoffs and interactions that are taking place behind the scenes at the API layer. You need to be able to not only understand those, but be able to isolate them and test them. You also get things like parallel development roadblocks. And what this is because microservices are so much more agile when it comes to redeployment and modification, you may have service versions or just services that are different than the environment that you have for testing. And so keeping track of all that and making sure that your understanding can be really difficult. And it impacts the way that we traditionally do test, especially when we start thinking about reactive event-driven architectures and the protocols and message formats and how we move from synchronicity to more asynchronous communication. How do we test that? And all this leads to more points of failure because of the ecosystem. But chances are, as I've been going through this, you're a little more intrigued by the blue ball machine on the right-hand side of the screen. And I think that really leads me into my last point, which is can be really distracting. We're already going through major transformations due to the pandemic and trying to provide digital experiences. We want to introduce a new architecture. Where does the time come from? And that's really what we're going to drill into today, is to provide you with 3 key strategies to help you maximize the ROI of your microservice testing. So it all really starts with our first strategy here, which is to increase your functional API test coverage with AI. And so for that, I'm going to go ahead and hand it over to my colleague Wilhelm here to take us through a demonstration. Wilhelm?
All right, thank you, Chris. Can you see my screen?
Yes, I can.
Fantastic. So for those of you watching today with deployment environments that are consisting of cloud infrastructure and microservices, you likely have your development organization segmented into agile teams that are all working collaboratively on webs of integrated services, orchestration layers, data layers, and we shouldn't forget those upstream client applications as well. It's also likely that your newer client applications are built on top of APIs. So with application teams under pressure to deliver, they're really grappling with these increasingly complex environments and test requirements. And to key off what Chris was saying, these complexities come with a real cost. If one of your end-to-end tests fails, you're now potentially disrupting multiple developers across several teams to diagnose the root cause of that failure. And to make matters worse, these exercises really get bitterly frustrating when the diagnosis points to like an environment issue or a deficiency with the test rather than actually catching a regression. And so I haven't even mentioned anything about slow execution time and high maintenance costs that is really common with functional testing through the UI. And so I wanted to bring all of this up because what we're about to see is an example of putting that misunderstood ROI Chris was talking about into practice. What I'm going to be doing is running a Java Selenium WebDriver test that I created using Parasoft Selenic here. And besides helping with Selenium test creation, Parasoft Selenic also has an AI agent that monitors your Selenium executions and adds enterprise functionality to open source Selenium. And so besides that, Selenic runs machine learning algorithms on the recorded data to make sure that there's recommendations and even self-healing when your locators break. Now, having said that, there's one specific workflow here that Selenic enables that's going to be relevant for our webinar today. I'm going to be using Selenic to run my Selenium test, and it's configured to capture the front-end API traffic between the browser and the application servers so that we can automatically feed that traffic into Parasoft SOA Test's AI, the Smart API Test Generator. And for those of you new to Parasoft, SOA Test is our codeless API testing framework where we'll be spending the bulk of this webinar. So let's run this test, and I'll walk us through the use case as we see it unfold. Once the browser comes up, I'll switch it over. There it is. So the application we're looking at is called Paratroopers. It's a military application where a general can come in and requisition various assets that get assigned to a campaign. These campaigns get published for an approver workflow. So there's a different user here that logs in. All right, we can see this requisition getting approved. Now we're going to log back in as the original user and verify that our requisition here got approved correctly, and we got through our whole workflow. And so, as you can imagine, with a UI like this that's built on top of APIs, there are a lot of various endpoints that are being called to transfer data, add an item to the cart, and the whole approval workflow, etc. And so one thing I want to point out here is, let's remember this. It took 50 seconds to run this Selenium test. But all right, folks, enough about Selenium. Let's go look at SOA Test. So here we can see in SOA Test, I have a new test that got created. And this was based off of the Selenium playback we just saw. So I'm going to rename this to a name that I want to call it Webinar Full Flow. And now when I open this, we can see what SOATest did for me. So here you can see we've got our login call. We've got various endpoints like pulling the categories to display those categories in the UI, right? Adding items to the cart. Then here we've got our login step where the approver, you can see there's a couple put calls here that it's updating the order status. Now here's the third login, logging back in as the original user, and then verifying the order. So pretty stateful. There's a lot of activity going on here. But besides just giving us a nice sequence of API calls from what we saw in the traffic, SOATest AI is doing something pretty incredible. So I'm going to expand this so we can see what it actually configured for me. And you'll notice that we've got these smart data banks kind of peppered through the test. And what these data banks are doing, the AI analyzed the traffic between all of these calls, and it identified cases where there's commonalities between like request and response, so that it can automatically configure these extractions, or what we call data banks, so that the test clients can be parameterized correctly. You can't simply just record these API calls and then play them back hard-coded as is. The way APIs are used by end user applications, it's just not that simple. You need to configure it this way so that it can be reliably playback. Besides just data banks, if we scroll a little further down, you'll also notice we've got some examples of assertions as well. And so the AI is also looking for opportunities where it notices that a particular field is changing what data it has as the APIs are getting called. And it's picking that up as an opportunity to create an assertion for me. So pretty awesome that just from analyzing the traffic, it was able to set all this up for me. I mean, if I were to try to stitch this by hand, it would take hours, if not days. Okay, so one other thing I want to mention. When we look at what Smart API Test Generator can do, it's also, I think, important to talk about what we see with customer environments. I've seen really impressive results when we tune the AI and unleash it against customers, custom Angular or React web applications. And as Chris mentioned, it's also really great for super dynamic enterprise applications like Salesforce or Guidewire. And so one thing I want to do before we finish here is I've got a number of calls here that I got to configure myself. And so in this scenario, remember we have those multiple user authentications we witnessed in the full scenario. And SOATest AI was configured to authenticate all these calls to the primary user, that purchaser user. But the approver user, they have different credentials and they have different access to the API resources that the purchaser doesn't. And so what I want to do is select these calls, and I'm going to use one of SOATest's nice quality of life features here, where I'm going to do like a bulk update, where I'm looking for the purchaser user, and what I'm going to do is just replace that with the approver user. The password is the same, so I don't have to worry about that. And now I think we're ready. And so what does everyone think? That 50-second Selenium test we saw in the browser, is that going to take half the time? Is it a quarter of the time? Well, let's find out. Wow, that took 1 second. Okay, so you're watching a webinar, and I'm sure you're wondering, that's great and all, but what about your customer environments and your customer experiences? So to reference one of our recent customer deployments, we saw the customer's approximately 20-minute Selenium test run about 45 seconds with the corresponding SOATest API test. And so you must be asking yourself this: if I had an AI-powered API testing workflow to simulate those complex UI scenarios I'm testing in Selenium, what would I do with it? Well, here's what our customers are doing. First, they're using these smart API tests as a quality gate in front of their UI test executions. If you're finding many of the root cause issues of those costly UI tests are rooted in the APIs, then you know your API regression suite just isn't robust enough. And this is your gateway to minimizing those painful debugging sessions at the UI layer that Chris was talking about. Second, they're achieving higher levels of functional test coverage. So speed and stability are definitely the factors at play here. You can run so many more API tests than UI tests reliably that it lets you just feasibly cover a lot more ground, both in breadth and depth. And so what we just saw was an example of breadth, where it's spanning 5 different endpoints across this end-to-end use case with multiple personas. In the next part of the webinar, we're going to explore a little more about depth and what we can do there. And then the third thing, our customers, they're shifting left their load and performance testing as well. With SOATest AI taming all of that recorded API traffic, you can not just use these as functional tests, but you can also quickly enable an API-first load and performance testing practice. And you don't need a specialized tool when you have Parasoft. And open source tools like JMeter definitely have their limitations where there's a high human capital cost to them. So using a framework like this can really help you make the teams more productive and efficient. So that's what I had for this section, Chris. Back to you.
Wonderful. Thanks, Wilhelm. All right, let me go back here to the presentation. So great demonstration on that, Wilhelm. Thank you so much. So in this first key strategy, what Wilhelm showed us was the ability to rapidly build API tests. Get those API tests. In the case that you saw, Wilhelm leveraged an existing Selenium test that he had to extract out those APIs. And what that does is it helps us to not only understand the APIs, but through AI to automatically create those chains linking the dynamic data together between different service calls. And that significantly increases the tester productivity. While at the same time, now I have an API test. I can run that as a part of my continuous quality suite and help draw down the time it takes for remediation. But a bonus that you get from this same strategy is, since you have the API tests, you're ripe and ready to then start creating load, performance, and security tests by leveraging those same tests. So it's really paving that foundation. So that's our first key strategy. Let's move on to the second one. So in the second one, things get a little more complicated. We start thinking about event-driven or reactive architectures. And in this strategy, we want to take you through how to automate the validation of those workflows. And so I'll hand it back to you, Wilhelm, to take us through that.
All right, thanks, Chris. Okay, so in the last demo, I mentioned we'd be talking about depth next. And so for those of you in the audience that are on microservice teams, you're really gonna like this next part. And so in this section, we're gonna look at 2 distinct use cases. The first use case is going to be exploring the importance of data permutation testing against your APIs. In the second use case, we're going to explore challenges that arise when a monolith starts transitioning to serverless microservice architectures on the cloud. And so for our first use case, it's important to note that there's a whole class of issues related to unexpected user input that both can and should be validated against your APIs. Now, the challenge is, how do you develop test data requirements to ensure that you're covering more than just those happy path scenarios? So let's take a look and see how that works in action. Here we're looking at the service definition, the Swagger for all those endpoints we were testing earlier. What I want to do is I want to take that and I'm going to use it to create a test template here in SOATest. And so I'm going to come in, create a new test, and let's call it Swagger permutation test. And we'll come in, we'll paste in that URL. It's the same one. All right. And so I want to look at, we've got all kinds of different APIs we can start testing. The example I want to show us today is related to this adding items or updating a particular item. And so we'll come in, we'll make sure this this test is authenticated. But more importantly, I want to look at one final configuration here and the payload. And so here you'll notice we've got a payload with a bunch of optional fields. I'm just going to turn them all on. Yeah, we can certainly do some happy path testing pretty easily if we've got some examples that maybe development shared with us. But I want to think about, what are the test data requirements? How can I set up a test to thoroughly validate this? So we're going to configure this REST client to point or to be parameterized with a data source, and it's our data repository data source. So let's call this webinar demo items. Give the data set name too. And so now SOATest is parameterizing all of these fields for my REST client here. It's creating the data repository data source for us and setting it up where we're ready to think about looping through this scenario with data. Now, instead of just looking here in the tool, I'm actually going to switch our attention over to another part of our solution called the Continuous Testing Platform, or as we like to call it, CTP. And so CTP has a number of components. Environment Manager, which is great for bringing tests and virtual services and data all together for your DevOps flows and testing. Service virtualization and API testing, essentially the browser-based thin client interface for creating, updating both virtual assets or test assets. And then this test data component, which is what I want to look at here. And you'll notice I've got this data set, webinar demo items that we created, and we've got one row of data here. And so what I'd like to do is introduce everyone to another data set. It's exactly the same, but I've configured it with our data modeling functionality here. And this is really where I get to start exploring those data requirements for my testing. So if we take a look at how I configured this, you can see I've got generation settings for these various fields here. And so if we look at in stock, for example, I've configured it where it's going to generate data between, it's a number between 0 and 100, right? And so that's how that's set up. If we take a look at another one here, description, this is actually pulling from a seed data source. So I've got another data source that I set up with a bunch of good data. In fact, we can go take a look at it so you can see what I'm using. And here, nope, this one. And so descriptions here, I've got a bunch of lorem ipsum text with varying lengths, right? And so, one of the things that you should think about is, the length of data that is being used for any particular field. That could cause some issues, definitely interesting for negative testing. And so what I want to do is use this this data set that I set up with the appropriate data model, and we're going to generate some data. And so we're going to create 10 rows of data, and I'm going to call this repository webinar demo items and generate it. All right, so if we take a look at what we got, you can see a variety of data for in stock here. If I expand description, we've got a variety of that lorem ipsum text we're pulling from seed. And so the reason I'm doing all of this, of course, is we want to come back and see what impact that has on my test here. So we'll just switch this, this data source over to generated here, the one we just set up. And I'll refresh that. Now let's run this test. You can see only half of the tests passed. So what's going on here? Well, what's going on is I guess some of that description text is just too long for the API, and the database has a specific limit on the field, and there's no validation being set up here, right? So this could be something that we could guard against, but we didn't, and now it's on the application team to guard against this. But you know, it would be great if the API did for them. And so it's a great thing to not only discover, but more importantly, you know, build automated tests for this, right? So that you know you set it up, and now you're just running it with every single build, and you're getting that validation. Okay, so that was the first use case here. To show the second use case, I need a few moments to get that set up. So if there's any questions, Chris, maybe we could field that for a moment.
Sure, absolutely. Actually, we looks like we have a global audience here because we got a question in Russian here. Well, we've translated it as, does Selenium work with microservices? And so it's a great question. We did show Selenium at the beginning. Yeah, in a roundabout way, yes, Selenium absolutely works with microservices because Selenium is testing typically the front-end system that is then interacting with those back-end APIs. But a more powerful approach is what Wilhelm demonstrated in the first part of the presentation, which was in the ability to then extract out those APIs, target them directly by re-leveraging that Selenium script. And then what he's showing here, which is communicating directly with those microservices, loading in the data, and then doing the validation. And in just a second, you're going to see how we take that one step further.
All right, almost ready. Give me a few more seconds here.
Okay, so the next question that we have, actually, I would like to ask a question. The question is, what's the difference between microservices and mini services? M-I-N-I, mini services. It looks like actually we've provided an article to talk about the difference between the micro and mini services to help that user understand that, and we'll post that into the broader chat towards the end. Thanks for the questions, guys. Keep them coming.
Great. All right, so I'm ready to go. And for this second use case, what I've got here is a legacy system that receives EDI inputs into the application. These EDI inputs, they're coming from partner integrations, and my company, they've begun breaking apart this system's business logic into back-end microservices that are leveraging AWS SQS, they're leveraging Lambda functions. And while some of you may look at this technology evolution with trepidation, we here at Parasoft, we see this as an opportunity where the environment is actually becoming more testable. So I want to see how this really plays out here with SOATest. We're going to run the same scenario 3 times and take a look and see what you might expect traditionally and what we can start doing with SOATest here. And so firstly, we're going to look at what happened when I ran this EDI client. Besides just REST and SOAP, as Chris mentioned, our solutions support a very large set of both message formats and transport protocols. And so here we're seeing an example of how we can create EDI clients quite nicely. Now the problem is when I run this client, I'm getting a 500 error back from the service, or the application. And to make matters worse, there's no payload. There isn't even an error code for me to follow up on. And this can be common with legacy systems where you just don't have enough visibility into what happened, and so it becomes really painful to debug when you have your functional test failing. And so with that, we're gonna take a look at what we can do with visibility and assertions in a moment. But first, I want to talk about what's happening behind the scenes. And so essentially what the team did is we've got this EDI message that's a purchase order, right? So there's a partner sending a purchase order into the system. And that purchase order, it's got various line items in there with quantities associated with the line item. And so the first piece of logic that the development team decided to break away from the monolith and build a microservice for, it was to transform that EDI message, look for all the line items, and then for each line item, send a message to this check inventory microservice that's deployed in AWS, and it's going to respond back with whether there's enough inventory or not. And so you'll see we've got a couple queues set up for that microservice that it's leveraging. And one of the ways that you can build visibility into your event-driven architecture is actually thanks to our SOATest sibling product, Parasoft Virtualize. And besides virtualizing environments, and we're going to really look at virtualize more in part 3 of the demo. What virtualize can also do is help us with proxying or being man in the middle between various applications that are integrated together. And so I created a couple additional queues in SQS, and so I'm now able to monitor the requests coming from the legacy system to the microservice and back. Now, there's another path you can take here with cloud infrastructure that's pretty cool. And some of you might be leveraging SNS here, or these topics. And this is great to sort of fan out messages to a bunch of subscribers. It's really important for event-driven architectures. And some of you might be using specialized topics specifically for like monitoring or telemetry, this kind of like metadata of what happened when a workflow gets kicked off. And so we can also be one of the subscribers to these special monitoring topics in our tool. And so kind of two different paths here depending on what your architecture is like. Now, if we come look at SOATest and see how this translates into the testing framework, you'll notice I have this event monitor tool here that's been set up to run in tandem with my EDI client. And this event monitor, it's been configured to listen in on our virtualized server here that, as I mentioned earlier, it's the man in the middle between the system and that microservice. We can also use the event monitor for subscriptions to topic endpoints as well. And what I did is I looked through those events, I transformed the ones that I was interested in, and now I've got this visibility, right? I can see, okay, so this example, this purchase order, there are 6 line items that got sent in, and here we can see true, true, oh, false, false, false. So this is why the response came back with a 500 instead of a 200. Now I know. That's pretty cool. But we can do more than just gain visibility. And as the name implies, if we take a look here at automated assertions, I've got the same setup, right? I'm sending in my EDI message, I'm monitoring events. But what I'm doing with those monitored events actually is I'm adding them to one of our dynamic data sources called a writable data source. So this is really useful to if you're running a test and there's a bunch of data that you want to extract and then put it somewhere so that you can iterate on it later. this is how you do it. And so we can see we've got these response messages that we've added up. And now I've got a test client that's just iterating over this. And I've got an assertion set up here where it's checking to make sure that all of them are true. Now, we can do many different kinds of assertions, like checking how many times a microservice was called, all kinds of good stuff. But the main point is not only can I gain that visibility, but I can also automate the assertions for that. And so that's really what you can do using Parasoft here for some of these more complex workflows where you're grappling with the complexity of those event-driven architectures. So, Chris, I'm going to pass it back to you.
Wonderful. Great presentation on that one, Wilhelm. All right, so in this second piece, what Wilhelm showed was how to get more visibility into the event-driven architecture. He started by taking that existing API test and creating a data model out of it, then generating a bunch of data on top of that, and then running permutation testing against the API. And that really helps, not only expedite the time to do that, but also to draw that down into the API layer so you can flesh out those issues. But then we took it beyond by then moving from the micro into the macro environment and looking at how all those microservice interactions communicated with each other, hijacking those calls by pulling into the Amazon event framework, pulling that data back into the system. And of course, this spans across any event architecture that you have, but then adding automated assertions on top of that. And this right here is really key to cracking the microservice problem and getting visibility. All right, so let's move on to our last topic here, which is now what we want to do is talk about a strategy for stabilizing individual services, isolating them, and enabling you to shift left your microservice testing. So pass it back to you one more time, Wilhelm. Take us through that.
Awesome. All right. So in this part of the webinar, we're going to focus on service virtualization. And by the end of this demo, you're going to see why just doing simple service mocking is another one of those missed ROI opportunities that Chris was talking about. And given the ground that we've covered so far, I can't think of a more appropriate use case than the Selenium test I ran in the beginning that was recording the API traffic. We already know the complexity behind that scenario, seeing those put and post calls that are changing the application state. And so to show you why service virtualization just puts simple mocking to shame, I've deployed this demo application locally on my machine here, right? So you can see localhost. And one interesting capability here in our demo application is that in the UI, it lets me dynamically configure the API endpoints that the application is calling, which just makes it easy to sort of hot swap what the downstream endpoints are to enable demos like we're seeing. And so your applications, they likely have this data as deployment properties that are managed by your DevOps team. And so here we can see that my local deployment is also configured for a local endpoint that's pointing to one of my virtualized message proxies here. And what I'm going to do in this demo is I'm going to take the exact same API traffic from the first demo that we saw, and I'm going to use Parasoft Virtualize to simulate the entire end-to-end stateful scenario and completely isolate this web application to my local machine. Now, I know that's a tall order I just gave myself, so let's see how Virtualize is going to make that easy for me. So I'll come back here. You'll notice that SoTest and Virtualize, they sort of live in the same ecosystem. They're, as I mentioned, they're sibling tools. And so we're going to go create a new virtual asset here. And let's give it a name. And we want to create it from traffic. And let's go find the traffic, right? It's whenever you create a test with Smart API Test Generator, besides the actual test, it also saves the raw traffic that was recorded for us. So I'm going to reuse that traffic here. And I'm also going to use a traffic template that I set up. And what these traffic templates do is it's basically saving the decisions I made about how to process this traffic and create virtual assets. So I'll give this a unique name for our data repository. And this wizard is quite powerful. What it can do is really incredible. I mean, here it's detecting sort of what the message types are. As I mentioned, there's a lot that we support beyond just JSON and XML. Here's really the cool part. So it's taking all of this traffic, and I've saved or configured how it uses that traffic to build various assets. So you can see all these endpoints that we know are part of the interactions between the UI and the backend. And so we've got these 34 unique messages that are paired, and then a bunch that weren't paired, right? So this is the HTML and CSS and all the stuff that we don't really care about. So I'm going to kind of zoom through this wizard here and get to the end. And then we'll talk about what some of these configurations are while we wait for it to finish its processing here. And so this is going to take a little while. It's going through all the traffic, it's creating the data repositories, it's setting up the virtual assets for us. And for some of these transactions, they're very stateful in nature. You call the same API multiple times, but you get different data back. We can, with the functionality in Virtualize, simulate that stateful behavior with our CRUD tooling. It's actually really powerful, and if you want to get a good look at that, we recently did a virtual sandboxes webinar that really explores that use case in detail. What I did here is I'm using one of Virtualize's newer tools called the sequence responder. And what that's doing is it's kind of shortcutting or short-circuiting the whole how to handle stateful responses. And it's letting me virtualize sort of the complexity of an end-to-end scenario like this without putting in the time and work to build a virtual asset that really simulates the behavior that we might be seeing when we run through these end-to-end scenarios. Now, here on the data reuse page, I'll also point out that it's not just do a single recording and then you're done. You can use these traffic templates here and do extra recordings, do more recordings, and you can tell the tool how you want it to merge the new data that it recorded, right? If it's exactly the same, do we replace it, overwrite it? And what's really nice about this is, we have some customers that have really sophisticated workflows where this whole process of recording traffic, building the virtual asset, deploying it in their environment, they automate the entire thing. It's really, really cool. And so now the last thing I want to do is give the virtual asset I'm going to create a unique endpoint. So we'll call this webinar virtual live, and I'm gonna copy this endpoint here. All right, and it's gone through the final steps. And now the last thing I need to do is reconfigure that message proxy I have set up. You'll notice it's pointing to an endpoint called webinar test. But now we're going to use the endpoint that we just created, right, from that recording. So I'm going to save this proxy. There's a little quirk with the demo application where when I make these hot swaps, I have to run a few API clients a couple times before the application picks up that things changed. And I've seen this sometimes where, like customers will warm up their APIs before testing. So their environment is warm, as they call it, and kind of a similar process here with my application. I just want to make sure that it's talking to the virtual assets, and yep, so now they're green. I run it again, it's fast, perfect. So the last step, what I'm going to do, come back to Selenium, and we're going to run that same test, except this time we're not going to the recording environment. We're going to the local environment that's now completely isolated from the outside world. And when the browser comes up, let me drag it over. So we're logging in, very good. Hey, all the categories are there, that's a great start. Troops are there, the cart showed up, the item in the cart, that's awesome. So now we're coming in, we're filling out this form, we're submitting the requisition. Okay, that all looks good. Approver, hey, it's there. And he's approving it. Okay, pretty stateful, but we're handling it. Now we come back in, we're going to check the status, and it's approved, right? The state of this changed throughout the course of the playback. And yeah, I did it without touching the outside world. And so what we just saw with my locally deployed demo application is that it's running in total isolation, right? And so what better way to optimize your DevOps pipelines and your regression testing workflows for front-end code? Now, there's one last thing. Remember that this is just one use case. We can do more than just record front-end APIs, right? We can also record traffic from API to API interactions and really help you isolate the appropriate application domains to facilitate those higher levels of automation and testing that your business is requiring. And then this is really how our customers are ensuring that microservices and these new industry trends aren't getting the best of them. So Chris, I'll pass it back to you.
Wonderful. Thanks for that, Wilhelm. Great presentation. Okay, so really in this third strategy, what Wilhelm was showing us was how to take service mocking to the next level with stateful virtualization. And stateful virtualization it's creating virtual services that think like the real services. They store their data. And in the example, Wilhelm was able to completely create an isolated environment for him to test those microservices and the event flows inside of the application. Of course, all of this can then be run continuously as a part of your CI/CD or DevOps pipeline through built-in integrations that we have with common build systems and cloud development and deployment architectures so that you can run the automated tests and deploy the virtual services as a part of your CI process. We have many customers that we've worked with over the years that have seen pretty major benefits from using technologies like this to crack open and get inside of their architectures and really focus down at the API layer. Three key use cases or takeaways from this is it really does radically simplify test creation process. By not knowing anything about the application, you can simply point the recorders and let Parasoft's AI help you understand what those APIs are and how they're connected together. That API awareness can only bolster your API testing practice and help you strive towards that ROI and actually achieve it. And then finally, something that's just personal to myself and Wilhelm as testers is this helps reduce something called tester fatigue, where when you have an application and somebody says, hey, I need you to test all the microservices, that's daunting. Where do I even start? And so by having technologies at your back and strategies to really dig in and get going fast and then create these stable environments, that fatigue goes away and people become excited about doing the API testing process again. And so that just about wraps it up. We have some more resources for you. I will remind you this webinar was recorded, and so we'll provide it for you in an email after the webinar here, but here's some links to help you get started understanding a little bit more about what you might have seen today in the webinar. And so we've got about 5 minutes and a whole load of questions. So I'll answer as many as we can in the next 5 minutes, and we'll take the rest of them offline. So if you do have any questions, go ahead and dump those in. I'll either get to them now or get to them moving forward. So let's just start here. We've got one here that says, does Parasoft support service virtualization? Yes, absolutely. Willem just showed how, it's funny, from the very first recording that we did with Selenium, we were able to create artifacts, and then Parasoft goes beyond simple mocking with that stateful virtualization, which really tracks how the data is changing, and all those pieces work together. Here's another one. Does it support CI/CD and running SOA tests in a delivery pipeline? Absolutely. So you imagine you would have a workflow where you've created your tests, you've associated them with the requirements, you then have a test flow that you want to execute every time you do a code check-in. Through Parasoft's native integration and a rich API, you can connect to the solutions from the build pipeline and execute those tests, deploy the services, reconfigure the proxies and the environment, all in automation, and then retrieve those results back into the pipeline so you can run full integrated testing extremely early in the process. And Wilhelm, I don't know if you wanted to add anything to that. I'm just going to look at some other questions. Okay, actually, here's a question. I see that you have simulated your application environment. Can this be run in a container? Absolutely great question. 100% this can. So Parasoft provides Docker images, Azure and Amazon images that you can just provision on the fly, programmatically deploy the necessary virtual services into the container, and then test against that container, reconfiguring it. And then store those obviously inside of your hub. Let's say you reproduce a defect and you want to store the combination of live and virtual services. You can easily do that inside of the solution. Okay, we have a question here about, you mentioned EDI and a list. What other message formats and protocols do you support? We support over 120 message formats and protocols. I think the easiest way for you to check out that list is to go to the parasoft.com website and then just look under the SOA test page at the technical specifications. That'll enumerate them. But at a really high level, it's a series of microservice IoT protocols, financial protocols such as Fix and Swift, and a ton more here. Let's see here. In the remaining 2 minutes, I'm going to choose some of these. This is an interesting question. Do you think manual testing is going away? I mean, absolutely not. In order for any of this to work, we need to be able to understand what it is that we're testing. Manual testing is the most important testing process. It's the only process that can thoroughly think like a human and try to validate our customer experiences. The power in what you're seeing today is in leveraging those manual testing activities. You're already doing them. So why not just turn the recorder on and then get your API tests and get your virtual services so that you can test something manually and then use that inventory that you're building to then build a rich and robust automated testing process. Okay, and then the last one here I'm going to answer is about getting access to the technology. Go ahead and head over to the Parasoft SOA test page here you see in the upper right. You notice there's a Try Parasoft button there. It'll get you everything you need to get started. Thanks. There's a lot more questions. We'll answer those offline, but thank you everybody for your time today. I hope this was insightful, and I look forward to talking to some of you in the future. So everybody stay safe and take care.